Hey guys, welcome back to section 12.3, chi-squared of independence. Alright, so this is question 7 on your homework, and here we're gonna try to do the same table of the testing. However, we're gonna use the chi-square test built in on Excel. Alright, okay, so let's start with this problem. So basically the question here is at the level of 0.01 level of significance, is there evidence of significant relationship between the identified main opportunity and the geographic region? So the two factors are, then it can be the main opportunity or identified main opportunity. That's one of the factors. And the second factor is the region, right? The geographic region. Okay, so this doesn't change anything from the null hypothesis. It's always the same. We need just to the two factors. So the first one, 80, there is no relationship. They are independent. The two factors independence means no relationship. All right. So what the first factor? Identify main opportunity. That's good. And regions. The second one, there is a relationship. That means they are dependent, right? A relationship exists between and the same two factors. So identified main opportunity and the regions. And this should do the first part. Great. Now for the chi-squared statistic, we're gonna go and download this table to our Excel. And let's open it. Okay, so once the table is downloaded, what you're gonna do is, again, same steps. You're gonna select the table, you copy it, paste it over here. It would be great if you paste it as values, and then you can go ahead and change the format with this one. So you're gonna keep the values with the format. We don't want any formulas in here, right? Okay, so what we are doing here, so although saying the identified main opportunity, this is our observed values, right? So I'm gonna just add it here. And for this one, it can be our expected values. I'm gonna add it there as well. Now, it would be great to select your table. So this table is having 4 columns and 5 rows. So let's give it a different color. We can identify the values. Over here, we're gonna select the same dimensions, which is 5 rows by 4 columns, change the color, and I'm gonna delete all the values in there. All right, so I need to do the calculation of the values. So the way we did it last video, we're gonna put equal sign. I'm gonna select the total of a row. I'm gonna lock it, then multiply it the total of the columns, which is 168. I'm not going to lock that one, and then divide by the overall total, which is 467, and I'm gonna lock it as well, right? So this is gonna generate the first value, and then to generate 4 more values, it's gonna be this way. All right, so that's if you want to do it horizontally. I will have to do the job again for each one of them. All right, so hang in there. So as you notice here, I did 3 on the row, and then I can drag them as well, same way. Okay, great. So now what you're gonna change from here is, instead of calculating these intermediary values here, which is f0 minus fe and the f0 minus fe squared divided by fe, we are not going to do these intermediary values. Okay, I just added this portion over here. All right, and this is the part of your table right here on your book. All right, so this part over here, I just copy it over there, right? Okay, let's go over it step by step. So the level of significance, which is according to your problem, is 0.01. The number of rows, you can count them here. There are 5 rows. The number of columns, same thing. There are four columns. A degree of freedom, so you can type the formula, which is equals. So you're gonna open a parenthesis, select the number of rows minus 1, close the parenthesis, multiply, open the parenthesis again, and you select number of columns minus 1, close the parenthesis, and enter. So that's going to be 12. So now what I'm going to be using is a function in Excel which is called the chi-squared test, and this is going to give you the p-value, right? So I'm going to go to the p-value equals sign. So I'm going to start with chi-squared, basically chi, and you can see the functions over there, right? So the one that you can select is chi-squared test. So you select this one, and you can ask you about the actual range. So the actual range is the observed values. So this is the actual range, the yellow part, comma, and then the expected range, and then the blue part. So you can select the blue part, and that's all. You enter and you get your p-value. So again, this one, if you want to select it, you're going to go to home, and what you can do, you can select numbers instead. So that's going to be 0, 0. And if you want to make it more values, so you can keep clicking on this. All right. So that's basically 0, 0, right? So that's the value. Now, how can I get the critical value and the chi-squared value? All right, so in this case, for the critical value, we're going to use chi-squared inverse. So for the critical value, we need the level of significance with degree of freedom. So you're going to be chi-squared, and then we're going to use inverse. We're going to need the RT inverse, so right tail, and you're going to input the level of significance with this one, and then the degree of freedoms, and that's it. So that's how you get the critical value on Excel. Now the chi-squared test, you can get it from the p-value and degree of freedom. It's very similar. So you're going to put equal sign and chi-squared and inverse RT, and you're going to select the probability. So the probability is right here, the p-value. Select that cell, and then comma, and then degree of freedom over here, and those, right? So we selected the p-value that we get with chi-squared test and the degree of freedom, and enter. So that's going to be 46. All right, our decision. So how can you make a decision? Is really simple. Either compare the critical values, or you compare the p-value with the alpha value, right? So this is your alpha value. All right, so if I want to compare the p-value with the alpha value, which is the most usual, so if the p-value is smaller than alpha, then you reject the null hypothesis. And for this purpose, we're going to use the if equals if, open a parenthesis. So the logical statement is going to be if the p-value is smaller, so if this one is less than the alpha value, then comma, you put your statement, so between quotations. So this is reject the null hypothesis, or 80. That's the first statement. Otherwise, you're gonna have the other statement, which is do not reject, between quotation again, do not reject, and close the parentheses, and that's basically it, right? Okay, so let's see whether this match our exercise or not. Okay, here you go. So we are looking for chi-squared stat, and chi-squared statistic is this value over here. We can copy it. Okay, we're gonna paste it over here, and we're gonna round to 3 decimals, so that's gonna be 3. Doesn't change this. 699. Check it. Good. And we're gonna look for the p-value. The p-value is right here. We got it already. We do the same, copy and paste, right? Well, this is assuming it's not 0, but this is obviously a 0, so we need 3 decimal places, and that's gonna be 0.00. Okay, good. And then we can make a decision here. So obviously the p-value is smaller, less than alpha, and the null hypothesis we say reject. So we reject the null hypothesis, and if you reject the null hypothesis, it means there is a relationship. All right, and again check this one and all set.